Hello everyone, my name is Shubhra Dash. Today I am excited to present the simplest yet powerful machine learning algorithm, the decision tree. In this short presentation, I will explain what the decision tree is, how it works, a simple code example, and its use cases in our real-life applications. A decision tree is a supervised machine learning algorithm used for classification and regression tasks. It works by learning some decision rule and organizing them into a tree-like structure, like this picture. A tree consists of a root node, some internal decision-making node, and leaf nodes, which are our final decision made by the decision tree classifier model. Here is how it works. A root node of the tree represents the entire dataset, and based on the most important feature, the dataset is split into some branches. Each branch leads to further splitting of the dataset or directly to the final decision at leaf node. Here in this example, we can see age is the most important feature, and depending on this feature and some condition, we are splitting the dataset into some branches and reaching the final desired class. But how do we find where to split the data? Well, we have some methods called Gini impurity and information gain. These methods help the model to identify or find the feature that best separates the data for classify our data to the separate classes. Here is a simple Python example with scikit-learn library. In some lines of code, we can build a decision tree classifier. In this output section, we can see that the dataset is splitted depending on some feature. Like the root node is represented by petal length feature, and splitting is occurred by some conditions depending on the most important features, and reaching at the leaf node and finding our desired output class. Decision trees have some real-life applications. Some examples include predicting loan approval in banks, diagnosing disease in healthcare services, filtering spam emails, detecting fraud transaction. Like all other algorithms, decision trees have some pros and cons. Decision trees are easy to understand, and it supports both types of data like categorical and numerical. However, decision trees are vulnerable to overfit by the training example, and it can easily be unstable with small data change. To address this issue, we have some techniques like pruning and ensemble of trees, such as random forests, are applied to solve this issue. This was all for my presentation today. Thank you for listening.